I'm going to talk to you today about a project we've been involved with APRO. And it's not just a Livermore project, it's a project that also involves our TriLab, which is Los Alamos and Sandia, as well as Livermore. It's called TLCC2. The 2 is kind of obvious, and that it is the second time we've been through this, so we're actually getting pretty good at it. What it is the TriLabs have a requirement to basically have a bunch of capacity computing, and we deliver that to our program through very large-scale Linux clusters. And to get kind of the economies of scales, the 3 labs came together and combined into one procurement instead of doing our separate procurements. And we deliver these systems to our users in our simulation environment and coupled that with basically a Red Hat Enterprise Linux, the typical thing you can go out and get, but we also add on top of that a hardened kind of HPC stack. That's what we call TOS, for TriLab Operating System Software, basically. The reasons we're doing TLCC is, not just because we need a bunch of computing, but in doing it in this way, in this type of procurement mechanism and the way we build it, which I'll get into, we reduce the total cost of ownerships of these systems, and that includes not only the cost of doing procurement, the integration cost, running it, support. We can deploy these things very rapidly, and I'll get into that here down the line. We can touch on some of this. I've kind of hit on it, but we obviously want these machines to be very robust production environments. It's a procurement that involves over multiple years. So not only is it 3 labs, but it's 2 government fiscal years. I'll get into the scalable unit concept, which we use to build these things out. It's kind of a Lego building block, and it gives us a nice, through the 2 years, kind of a longer-term partnership with our integration partner. So this procurement involves, close to $40 million. We actually have options in it to go up to about 90 million, so it is significant. As I mentioned, it delivers machines to all 3 sites over 2 fiscal years, and the extra in there, the kind of 50 million extra, is basically for options. We don't know what, either from our programs or other programs that we're involved in, may need computing, and they can leverage this procurement mechanism as the money comes in. So the scalable unit. This idea kind of originated where we wanted to have, in a sense, a Lego building block that we could start with that was very simple, have vendors focus on that as opposed to the full system, and mainly because when we're buying multiple clusters, we may not know right away how big they are. And so what we wanted to focus on in architecture is kind of replicable and Lego-like. So with the quad data rate InfiniBand, a fairly large switch is a 324. You can also get a 648, but that's a little too large. So we stuck with 324. And if you imagine a fat tree kind of network, you'd have half of those links going down to nodes, 162 going down to nodes, another 162 go up to the next stage of the fabric. So that kind of gives a size for the scalable unit of 162 nodes. Now, most of those are obviously compute nodes, where you're running your job and stuff. Those are the ones up on top. In this case, it's 154. We also have nodes that basically take us from the cluster interconnect, the blue InfiniBand interconnect, out to our SAN network, which connects to our parallel file systems, for example. That's done through the green gateway nodes. There's 8 of them. And those either connect in through 10 gigabit Ethernet or InfiniBand, depending on if it's Livermore or Los Alamos or Sandia. And then, of course, we have what we call an LSM node. It's basically a login node. That's where the users get on, compile, et cetera. And then an RPS node, which is basically the management node. The gateway nodes and all the compute nodes boot disklessly from the RPS node. And I'll show you some other pictures, but you can basically combine these scalable units into either one standalone or 2 or 4 or 8, or we even built one that I'll show you that's 18, about 3,000 nodes. And then the management node, everything scales because it's just a Lego building block. Now, we've deployed several systems. I mentioned the largest is about 18 SUs, but which is 3,000 nodes. We've delivered so far about 5,000 nodes to the TriLabs, and these are the first large-scale Sandy Bridge clusters to be delivered. You can see the specs there. It's 32 gigs per node, so 2 gigabytes per core, 2.6 gigahertz processors. We're using QLogic QDR InfiniBand. We have some options also that mainly right now Los Alamos is looking at for a few clusters where they will have 2 GPUs per node as well, but predominantly most of them are not using GPUs. And we even have a few of the clusters, including some at Livermore, that we're looking into perhaps putting SSDs in each compute node, mainly to accelerate checkpoint restart type capabilities. And it's more of a researchy thing right now, but something we're looking at as we kind of march along here towards exascale and some of those requirements. Now, here's basically how we take the scalable unit and combine it up. So if you can imagine that the integrator is kind of focusing on building these scalable units and just building them up, then we can combine them not at the integrator site, but at each laboratory into larger ones. You can see the listing here. And almost every one of these, at some scale, we're building between the 3 laboratories. And it makes a nice, easily replicable way to leverage it. So if you can build a very large one first, which is what we've done, work out some issues, and you can deliver the second, third ones. You've learned a lot more. You can deliver them a lot more quickly. And here's a listing of the ones we have kind of coming online. These, let's see. This Hype one has been delivered. Zen, which is the largest. I think that hit number 15, was it? In the top 500? Yeah, so Zen is 15 on the top 500 here. We actually think we can get a better LIN pack than that. We are on target to get over 90% efficiency, but ran into some MPI scalability problems that we're running through. We'll have a few other deliver more here in the next several months, and then Chama and Luna are almost delivered to Sandia and Lanel now, and then you see all the others there. So quite a few of the clusters here. Here's some pictures of Zen as it was being built up. You can kind of see some of the work being done there. But this is the largest one. Being in Livermore, California, wine country, they decided to start naming them after wines, so Zen for Zinfandel. But this, we built a machine that was 12 SUs about a year ago, so 2,000 nodes, and this kind of stretches it to the next level of 3,000. So, as I said, we're currently working through some issues there, but so far this machine has been very stable and extremely fast, and we're currently getting some benchmarks through it. So, thank you. I'm happy to answer questions. There's a lot more details here that I could get into, but couldn't with limited time. But here's the questions, I guess, for the prizes, and I'll take any questions.